Concurrency questions are among the most common in senior Java interviews, not because they're exotic, but because they're genuinely dangerous when misunderstood, and every experienced engineer knows it. The interview is really asking, do you know where the bugs hide? Three categories of concurrency problems. Race conditions. The result depends on which thread runs first. Two threads read the same counter, both increment, both write back. One update is lost. Simple, common, and silent. Visibility. One thread's write isn't visible to another because the JVM can cache values in CPU registers or reorder instructions for optimization. The code looks correct, the behavior isn't. Deadlock thread. Juk holds lock 1 and waits for lock 2. Thread B holds lock 2 and waits for lock 1. Neither proceeds. The system freezes waiting quietly. The synchronized keyword acquires an intrinsic lock on an object. Only one thread holds that lock at a time. Everything else blocks. Synchronized on a method acquires the lock on this. Synchronized on a block lets you choose the lock object precisely and keep the locked region as small as possible. Smaller scope means less contention, more throughput. Volatile is visibility, not atomicity. Marking a field volatile tells the JMM not to cache it. Every read hits main memory, every write is immediately visible to all threads. But volatile doesn't protect compound operations. Count plus plus is 3 steps. Read, increment, write. Volatile doesn't make that sequence atomic. For compound operations, use synchronized or an atomic integer. This distinction is the classic interview gotcha, and the one that trips the most candidates. When synchronized isn't enough, reach for re-entrant lock. Try lock lets you attempt to acquire with a timeout instead of blocking indefinitely. Fairness mode gives the lock to threads in the order they requested it. Always unlock in a finally block. A thrown exception will otherwise leak the lock permanently. Arduino. For read-heavy workloads, read-write lock is powerful. Multiple threads read concurrently. One thread writes exclusively, blocking all readers. If most of your access is reads with occasional writes, this dramatically cuts contention. Atomic classes, atomic integer, atomic reference. Use compare and swap at the hardware level. No locks. Lock-free single variable updates. Use them for a single shared counter or reference when you don't need to coordinate multiple variables together. Fast, correct, no deadlock risk. Concurrent hash map instead of synchronizing a hash map yourself. It uses fine-grained locking or compare and swap internally, so different threads can operate on different segments concurrently. Much higher throughput under load. Blocking queue for producer-consumer. Put blocks when the queue is full. Take blocks when it's empty. The queue manages all the synchronization. Your producer and consumer threads never coordinate directly. This is the cleanest pattern for thread communication. 3 approaches to deadlock prevention. Consistent lock ordering. Always acquire multiple locks in the same order across all threads. Try lock with timeout. If you can't acquire within a limit, release what you have and retry. Minimize scope. Hold fewer locks simultaneously. You can't deadlock on a lock you're not holding. The question that defines senior candidates: what's the difference between volatile and synchronized? Volatile. Visibility only. No atomicity, no mutual exclusion. Synchronized. Visibility plus atomicity plus mutual exclusion. Both in force happens before in the JMM. That last sentence is what separates good from great. Also know, synchronized hash map versus concurrent hash map. Synchronized hash map logs the entire map for every operation. Concurrent hash map logs at segment granularity. Dramatically better throughput when multiple threads are active. Concurrency is where correctness is hardest to see and bugs are hardest to reproduce. Know your tools, know their guarantees, and whenever you write shared state, ask what happens when 2 threads hit this at the same time?